All right, everyone. Today we are learning about divisibility, and today there'll be certain rules that we need to know so that we can tell whether a number is divisible by another number, right? So these will make it much easier and much faster to see whether a number is divisible, so that we don't have to literally go through the entire division, or we don't have to use a calculator. So let's take a look at these rules, students. How do you tell if a number is divisible by 3 or 9? That's the exact same rule. Okay, the same rule. Why? You just need to find the sum of digits in order to tell whether a number is divisible by 3 or 9. What does it mean by sum of digits? Okay, imagine you have this number. Then you ask yourself, is this number divisible by 3? I mean, if you use mental calculation, straight away you know the answer is 41, right? If you divide it by 3. So it is divisible by 3. So let's do an experiment. You take the sum of the digits. This digit plus another digit plus the other digit. You add the digits together, you get the sum of digits, 6. Whenever the sum of digits is divisible by 3, the entire number is divisible by 3. So can you see 6 is divisible by 3? That means the entire number 1, 2, 3 is divisible by 3. And is it divisible by 9? Nope, it's not divisible by 9 because 6 cannot be divided by 9. Therefore, the number 1, 2, 3 cannot be divided by 9. Okay, so very quickly we can tell whether a number is divisible by 9 or divisible by 3 just by adding up the sum of digits. Why not we do a very quick experiment? Everyone, can you tell me whether this number is divisible by 3? Yes or no? Just type in the chat, yes or no? Very good. When you add all the digits together, you get 35. Right? You add all the digits together, you get 35. And the answer is no. Because 35 is not divisible by 3. Neither is it divisible by 9. Okay? So it cannot be divided by 3, it cannot be divided by 9. Now, what if I do this? Imagine you have a 6-digit number, and I tell you that this number is divisible by 3. Okay? If I tell you that this number is divisible by 3, what is the value of x? Can you tell me what is the value of x? What is a possible value of x? Any of the possible values of x. Very good, students. X can be, okay, because you already know that 9 plus 8 plus 7 plus 6 plus 5 equals to 35. Now let's write down the sum of digits. The sum of digits is 35 plus x, and we must make sure that 3 can divide 35 plus x. Okay, that means 35 plus x is divisible by 3. So what can the possible value of x be? X can be 1, 4, 7. Okay, it can be 1. If x is 1, you get 36. If x is 4, you get 39. If x is 7, you get 42. Okay, can x be 10? No, because x is a single digit number. 10 is already 2 digits, so no, you can't be 10. Okay, so x can be 1, can be 4, can be 7. Very good, students, well done. So this applies to the number 3 and the number 9. Let's move on to the number 4 and 8. In order to tell if a number is divisible by 4, you just need to look at the last two numbers. Okay? Last two digits. If you look at the last two digits, then if the last two digits are divisible by 4, then the entire number is divisible by 4. For number 8, you look at the last 3 digits. Easy, very easy. Look at the last 2 or the last 3 digits. That's it. How about number 7? Divisibility of 7. So 7 and 13 are very similar to each other. Okay? just that 7 has something extra. Now, for 7 and 13, the rule about the last 3 digits and the rest of n. Okay, this rule, right? These two rules are the same for 7 and 13. What does it mean? They're asking you to, okay, let's consider let's consider this number here. You take the first 3 digits and the last 3 digits and you find the difference between them. If the difference between them is divisible by 7 or divisible by 13, then the entire number is divisible by 13 or 7. Okay, for example, 222 minus 222 is 0, right? And 0 is divisible by anything. 7 and 13, both. That means the entire number 222 is divisible by 7 and 13. Come, let's take a look. 222 divided by 7. Yes, it's divisible. 222 divided by 13. Yes, it's divisible. Okay? So, taking the difference between the first and the last 3 digits, that means any block of 6 digits, any block of repeated 6 digits is divisible by 7 or 13. It can be 222, 333, 444, whatever, all the way until 999. All these numbers can be divided by 7 and 13. Now, but 7 has something a little bit different. There's another rule here, the first rule of 7, which is different from 13. Okay, this rule states that in order to determine if a number is divisible by 7, okay, let's say you have 123. You want to know whether this is divisible by 7. You take the last digit, number 3, then you double it, right? And you subtract this from the rest of the remaining number. Okay, so you took out the number 3, so the remaining number is 12. Okay, so 12 minus double of the number 3. So then you look at the answer. Oh, is this divisible by 7? No. That means the number 123 is not divisible by 7. Okay, so how do you, if you want to make it divisible by 7, what should you do? You just change this to a 3. You see, if I change this to 13, right? Then you realize that 13 minus 6 equal to 7. And 7 is divisible by 7. So, 133 is divisible by 7, but 123 is not divisible by 7. There you go, 19. How about 123? 123 cannot. You will end up with decimals. Uh-oh. So can you see, students, these are the rules that we can use to determine the divisibility of 7 and 13. Okay, but 7 is a little bit different from 13. And now number 11. In 11, you must find the alternating sum of the digits. Just now for number 3 and number 9, we just find the sum of the digits, right? But for 11 is the alternating sum. Okay, so let's say we have this number. What is the meaning of alternating sum? That means you take this is positive, then after that, negative, then positive, then negative, then positive. That is the meaning of alternating sum. Instead of just finding the total sum of all the digits, you must find the alternating sum of digits. So let's add these together. 1 minus 2 is negative 1. Plus 3, then you got 2. Minus 4, you get negative 2. Plus 5, the final answer is 3. Is not divisible by 11. Okay? So if I write down the letter X here, and I give you this 6-digit number and I ask you, what is the value of X such that it is divisible by 11? What are you going to say? What is X, students? What is X? I see some answers from Koji. Who else? Koji, who else? Jacobs also gave me an answer. Who else? Koji, you change your answer. So then if you want it to be divisible by 11, right? Try to make this become 0. Okay, we find the alternating sum, then the last digit is x, so you put minus x. Because it's plus minus plus minus plus minus, right? Put minus x here. You try to get 0. Because 0 can be divided by anything, including 11, right? You try to get 0, what is x? Well done, well done. X is supposed to be 3, okay? So if x is 3, okay, so you minus 3, you get 0. That means the number is 1, 2, 3, 4, 5, 3, which is supposed to be divisible by 11. 1, 2, 3, 4, 5, 3 divided by 11. There you go. 1, 1, 2, 2, 3. Okay, students. Any questions about alternating sum? Alternating sum. Start from the positive, then you alternate negative, positive, negative, positive. That is the meaning of alternating sum, okay? So everyone, these are all the rules of divisibility. Do you have any questions? Raise your hand. Anybody? Okay, then let's try some questions. Let's look at example 1. Now, over here they say that there's a 5-digit number that's divisible by 3 and 5. Now, if you want a number to be divisible, let me ask En. If a number is divisible by 5, how can you tell? What is the rule?
The last digit must either be 0 or 5.
Good. Okay, so we write down since 5 divides this number, therefore we can say B must be 0 or 5. Students, you realize that multiples of 5, right? They always finish in a 0 or a 5. I say 25, 30, 35, 40, 45, 50. They either end with a 0 or a 5, right? So we know that B must be 0 or 5. So let's look at scenario number 1. If B equals to 0, then what is the rest of the numbers going to be? And we can also look at case 2. If B equals to 5, what's going to happen? So let's look at B equals to 0, okay, En. So, En, what is the rule to tell whether it's divisible by 3?
You take the sum of digits, and if the sum is divisible by 3, then the whole number is divisible.
Very good. Well done. You find the sum of digits. Okay, so when you look at B equals to 0, how do I find the sum of digits? You take 1 plus what? And continue.
5 plus 8 plus 8 plus 0.
Very good. Okay, this is supposed to be B, but now we are saying B equals to 0. If B equals to 0. So tell me the sum of digits.
It will be 14 plus 8.
Good. Okay, so 14 plus 8. So the sum of digits is 14 plus 8. If I want to make sure that this is divisible by 3, so you must make sure that 3 divides 14 plus 8. Therefore, A could be, what is the value of A?
It could be 1. It could be 7.
You missed something.
Could be 4.
And 7. Very good. You know how you get it? You just take 1, then you plus 3, then you plus 3 again. Right? Okay, so you just keep adding 3, then you get everything. 1, 4, 7. Okay? Can it be after 7 is what? 10. Can it be 10?
No.
Why?
Because A is a single digit number.
Very good. Now let's look at if b equals to 5. Okay, if b equals to 5, let's find the sum of digits. Okay, what is the sum of digits?
1 plus 5 plus a plus 8 plus 5.
Yes, and what do we get?
You get, wait, you get 19 plus a.
Okay, you get 19 plus 8. So, in order to make sure it's divisible by 3, we need to make sure that 3 can divide 19 plus a, and that means that a equals to
Equals to, we can have 2, 5, 8,
11.
no,
No, very good. So it's only 2, 5, or 8, right? Well
Yeah.
done, En. Well done. Thank you, En. So students, can you see what we did here? First, you use common sense to know whether a number is divisible by 5. I mean, number 5 is not one of our rules. We did not have this in our divisibility rules because it's too easy. Alright, you just need to end with a 0 or 5. So once you know that you need to end with a 0 or 5, you have case number 1 and case number 2. Each case have different outcomes. So in case number 1, a can be 1, 4, 7. In case number 2, a can be 2, 5, or 8. So the question is asking you to find all the possible digits. The possible digits represented by a. So the possible digits are 1, 4, 7, 2, 5, 8, and there you go. Okay, students? First you test for whether it's divisible by 5. Then you test whether it's divisible by 3 by finding the sum of digits. Questions, anyone? Okay then, let's do a practice question. Again, they want you to find the possible digits. Find the possible digits represented by a and b for the 5-digit number 25A 4B. Okay, to make sure that it's divisible by 3 and 5. Again, you can use case 1 and case 2. Okay, you let your b be 0 or let your b be 5. Students, can you just type? I don't need you to tell me b. B is either 0 or 5. Tell me a. What is the possible values of a? Can you type your answer in the chat, please? So let's get started. Lian, how do you know whether a number is divisible by 5?
Last digit is 0.
Last digit is?
0.
Okay, so we write down since 5 divides 2, 5, 4, 5 divides 2, 5, a, 4b, it means that b must be 0 or 5. So in the first case, let us consider case number 1, where b equals to 0. Then we can consider case number 2, where b equals to 5. So tell me, when b equal to 0, Lian, what is the sum of digits? How do I find it?
2 plus 5 plus 8 plus 4 plus 0.
Excellent. What do you get?
11
11 what?
plus 8.
Okay. Now, must this be divisible by 3?
Yeah.
The sum of digits, 11 plus a. So, number 3 must be able to divide 11 plus a. Therefore, what are the possible values of a? Such that
1, 4, 7.
1, 4, and 7. Very good. 1, 4, 7. Now, let's look at case number 2. Sum of digits equals to, how do I find it?
Goes to 2 plus 5 plus 8 plus 4 plus 5.
Good. And what do you get?
16 plus
16 plus a. So 3 must divide 16 plus a. Therefore, a equals to
4. 8 equals to 2.
Sir, what?
2 and 8.
Yes, Lian, well done. So how? Easy or difficult? Okay, well done, Lian. Stop copying, stop copying. You see, so busy copying that you can't even answer me. Okay, I tell you what, the solutions are uploaded. Copying is not important. During class, you just pay attention, right? And you make sure you ask questions. Then you will learn more. Don't be so busy copying, okay, students? Now, let's move on to question number 2. Find the sum of all numbers smaller than 100 that can be divided by 2 and 3. So, students, find the sum of all the numbers. The sum. Okay? That are smaller than 100 and can be divided by 2 and 3. Now you ask yourself, what is the LCM of 2 and 3? 6, right? So literally, what are you referring to here? We are referring to the multiples of 6. Okay, any multiple of 6 can be divided by 2 and 3. Okay? So students, basically they're just trying to tell you, find the sum of all the multiples of 6 smaller than 100. Go ahead. Okay, you just find the sum. Okay, what is the sum? All the multiples of 6 that are smaller than 100. Can you please find it? Your time starts now. Type your answer in the chat. This should be easy. Okay, Matthew. Remember when we want to add a string of numbers together, what method can we use? Jacob's very good. Matthew, what method can we use, Matthew?
The rainbow thing.
Rainbow method like that? Can, no problem. Okay, what is 6 plus 96?
102.
Then 90 plus 12?
102.
So no matter what, you will still get 102, right?
Yeah.
So then my next question to you is, how many numbers do you have altogether? From 6 to 96. Okay, so from 6 to 96, then you have 15 numbers. Yes or no? Not sure, right? Come on, let's try. 6, 12, and 18. Tell me how many numbers are there from 6 to 18?
3.
3 numbers. Okay, let's calculate. No lah, there's only 2 numbers. What? Am I correct? There's only 2 numbers. Am I correct?
No.
What must I do to make it correct?
+1.
So what must I do here to make it correct?
+1.
So how many numbers are there from 6 to 96?
16.
Yes. Okay, why must you plus 1? The reason behind why must you plus 1 is because whatever you get here, right, 15, right, is actually the number of intervals. That means the number of blanks, the number of intervals between all the numbers. So can you imagine these are all the numbers? You're only finding how many blanks are there between them, how many intervals are there. So you plus 1, okay, you plus 1, then you get the number of numbers. So students, remember plus 1. Okay, so now you know you have 16 numbers. That means how many pairs of numbers can you make?
8.
8 pairs of 102. Very good. So Matthew, you know where you went wrong now?
Yeah.
It's because of the pairing, right?
Yeah.
Okay, thank you, Matthew. Well done. Now, students, this is how we do it, rainbow method. But actually, there's another method which I find very useful as well. It's called Gauss summation. So let's delete this. We're going to try to use Gauss summation, which is very, very similar to the rainbow method. You just take the first number plus the last number, multiply by, how many numbers are there? 16. Then you divide by 2. Actually, this is just trying to find the number of pairs. Right? How many pairs of numbers are there? So in the end, you still get 102 and you have 8 pairs of them. And you still get the same answer. Okay, it's just a different method. Now, why do I prefer Gauss summation? I prefer Gauss summation because you don't need to worry about how many pairs can you form. Because if I have a, let's say number 1 plus 2 plus 3 plus 4 plus 5, and if I want to use the rainbow method, I realize that this guy does not have a partner. Okay? But for Gauss summation, we don't care. For Gauss summation, I just need to write down the first number plus the last number. How many numbers are there? 5 divided by 2. I don't need to care. This guy does not have a partner. It doesn't matter to me. So I'll just get my answer like that. Divide by 2, divide by 2. I'll just get my answer like that. Okay? But if I use rainbow method, then I need to be careful. Somebody does not have a partner. So if I use rainbow method, 6 plus 6 plus 3, then I need to remember the number 3. Okay, sometimes you get careless, you forget to add the number 3, that's it. Okay, so let's take a look at question 3, students. Now you have a 4-digit number being formed by selecting 4 digits from 0, 1, 4, 7, 9. And the numbers that are divisible by 3 are arranged in an ascending order from smallest to biggest, okay? Smallest to biggest, ascending. Find the 10th number. So basically, when you form some 4-digit numbers, they are only interested in the numbers that are divisible by 3. So let me ask Jacobs, how do you know whether a number is divisible by 3?
You find the sum of numbers.
Sum of what?
Sum of the numbers. The digits.
Yes. What's the difference between a digit and a number?
The digits like 1, like...
The digits, numbers are made of?
Digits.
Very good. Okay, now the numbers are made of digits. Okay, so when you talk about 4-digit numbers that are divisible by 3, they already gave you these 5 digits here. Can you choose 4 digits that you know is definitely going to be divisible by 3 when you find the sum of digits? How about 0, 1, 4, and 7? Do you think these will definitely be divisible by 3?
Yes.
Okay, you add together, what do you get?
12.
12. Very good. So students, take note. Okay, let's do scenario number 1. You use the number 0, 1, 4, and 7. Okay, why? Because we know that 0 plus 1 plus 4 plus 7 is 12. So, Jacobs, if 0 plus 1 plus 4 plus 7, right, equals to 12, no matter what number which 4-digit number I form, no matter what I do, do you think this will be divisible? All these numbers will be divisible by 3?
Yes.
Yes, because all their sum of digits are 12. So no matter what I do, any number I form will definitely be divisible by 12. So let's form some numbers starting from the smallest. What is the smallest number you can form?
1047.
Then 1074. Next,
1407.
then 1470. Next,
1704.
then 1740. Very good. How many numbers so far?
6.
Can we form any other number using 0,
Yeah.
1, 0, 1, 4, 7?
No. But yes.
What? Starting with 4, right?
Yeah.
And starting with 7, right? Like you can
Yeah.
form like 4,000 and something or 7,000 and something, but you know what? That's a little bit too big because we are trying to arrange numbers from smallest to biggest. And if you have 4,000 and 7,000, those numbers will be somewhere at the back. So let's just stop here first. Let's just write ... first. Study case number 2 first. What if we use the numbers? Okay, can you select another 4 numbers that can definitely be divisible by 3 when you find the sum of digits?
1, 4, 7, 9.
Yes, very good. And what do you get when you add these together?
21.
That's definitely divisible by 3. So we use these 4 digits to form some numbers from smallest to biggest. Come, start from the smallest. What do you get?
1479.
Then 1497. Next.
1749.
Then 1794. Next.
1947.
Then 1974. Now you can go on, right? You can do like 4,000 something or whatever, but those will be quite big. So now we look at all the numbers that we have, we arrange them in ascending order. Okay, so we have the smallest ones, 1, 2, and what's going to be next? 3, 4, 5, 6, 7, 8, 9. What is the 10th number, Jacobs?
1794.
10. Very good. So now, what do you think? Is it easy to do this question? You understand what happened here?
Yes.
Well done, Jacobs. Anyone have questions about these students? Okay, so that's what we did. We noticed that this is the 10th number. There you go. Okay, so let's try the next one. Example number 2. Find the smallest possible. Okay, so just highlight this, smallest possible. Find the smallest possible 6-digit number such that it is divisible by 36. Students, when you see 36, right, you know that it is 4 times 9. So if you want a number to be divisible by 36, then you need to make sure it is divisible by 4 and also divisible by 9. Koji, can you tell me, how do I know if a number is divisible by 4?
If the last 2 digits are divisible by 4.
Yes, if the last 2 digits is divisible by 4. So you can say since 4 must divide the entire 15ABC6, therefore the last 2 digits, what is the possible value of this last 2 digits, C6? Or maybe what is the possible value of C? Hey, sorry, you're muted. Yeah.
C can be 1, 5, or 9. Oh yeah, 1, 3, 5.
13579. Okay, if C is 13579, what does it mean? That means C6. Okay, that means C6 is gonna be 16, 36,
56, 76, 96.
Yeah, and all these numbers are divisible by 4. Very good. So now we know what is C. Now you want to find the smallest possible. So we write since 15ABC6. Okay, never mind. I just want to write down this. Let A equals to 0 since you want 15ABC6
Be small.
yes, to be the smallest. Very good, Koji. You know what I'm doing. Well done. So you let A is equal to 0 so that you can get a small number, as small as possible, okay? Now it is time to see whether it's divisible by 9. Am I right? So what is the
Yeah.
sum of digits?
1 plus 5 plus 0 plus 6.
Don't forget the C.
Oh yeah. And B.
Oh yeah, yeah. The B. Oh yeah. I forgot the B. You forgot the C. Okay, so we write down B, C, 6. Come add this together for me.
That would be 12 plus B plus C.
Yes. Now, if you want 12 plus B plus C to be divisible by 9, okay, let's write down, since 9 must be able to divide 12 plus B plus C, therefore we can say B plus C. What are the possible values of B plus C then?
Oh, that would be anything that adds up to 6. So 3, 3, 5, 1, 4, 2, or 6.
Oh no, so B plus C is equal to 6, is it?
Oh yeah, yeah.
Yeah, because if this is equal to 6, that means 12 plus 6 is 18. 18 can be divided by 9. Can it be 15?
70.
Can it be 15?
Oh yeah. Yeah, it could be.
Yeah, because if this is 15, right? 12 plus 15 is 27. 27 can also be divided by 9, right? Can it also be 24? Because 12 plus 24 is 36.
No.
Why not? Why not? Why not?
Because B plus C at the max would be 9 plus 9, that's already 18, so it can't be.
Very good, Koji. Students, these two are single digit numbers. The maximum value is 9 and 9. Okay, the maximum you can get is 18. You can never get 24. Okay, so it's either 6 or 15, but which one do you think you want to choose, 6 or 15?
Probably 6.
Why? Why?
Oh, because we want to make it the smallest.
Yes, because the question wants you to make the smallest possible value. Okay, so let's take a look. B plus C equals to 6. So what do you think we should do next?
Make B1 C5 because
You want B to be small, right? Because B comes
Yeah.
first. Okay, so when B comes first, B has a higher place value. It has a higher place value. So therefore, we can say that the smallest possible value is 1.
5 or 1 5 6.
Well done. Thank you, Koji. Good job. So students, you see, you have 150. Remember, we let A be 0. Then 156. Why is it 15? This is B. This is C. Okay, we make sure that B is as small as possible. But why not? Then I have another question for you then, Koji. If you want B to be as small as possible, why not let B be 0?
Because A is already 0.
Because A is
Otherwise it'll
already
be 1
0.
5 A C6.
Yes, very good. Thank you, Koji. Students, because A is already 0, it's supposed to be A, B, C, 6. Okay, you cannot have A, C, 6. So A is 0, B is 0. A is 0. A is already 0, so B should be 1, right? Actually, I feel that, Koji, if you read the question, they did not say that A, B, and C are unique. So actually, they did not say that A cannot be the same as B. They did not say that. Okay, so we cannot just give that reason. We cannot say that A and B must be different. Actually, the main reason why you must have B equals to 1, right, is because we already know that C can only be equal to 1, 3, 5, 7, or 9. So if you have B equals to 0, C equals to 6, that's wrong. Then you will not be able to divide the number by 4. So C can only be 1, 3, 5, 7, 9. Okay? So therefore, B must be 1. C must be 5. That is the real reason why we cannot let b equals to 0. Okay, let's try practice number 4. So students, a 6-digit number, again, 15ABC6 is divisible by 36. So that means you must make sure you can divide by 4 and divide by 9, right? Straight away, we can write down the same thing. Okay? I can even copy and paste this. Copy and paste. So we are doing exactly the same thing. If it is divisible by 4, then C can be 1, 3, 5, 7, or 9. But are we going to let A equal to 0? No, I don't think so. I think you should let it be something else, because you want it to be the largest. Alright. So you want, this time round, they're asking for the largest possible value. Okay, so you must let A be something else. I don't know what, but it's pretty obvious lah. Then you find the rest of the numbers. Okay, students? So I'm going to let you refer to the previous example, just in case you need to refer. And I'm going to give you 2 minutes. Can you give me your answer in the chat? Your time starts now. Alright, come CJ, let's try this. Okay, CJ, if I want my number to be as big as possible, what should I let A become? A is over here. What digit should it be? 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9?
9.
9, yes, because I want it to be as big as possible, okay? So if A equals to 9, so then we will say the entire number is as large as possible. Sum of digits. Let's find the sum of digits. So, wait, hold on. Before I move on, right, CJ, just to confirm, you understand why C must be 1, 3, 5, 7, 9?
Yeah.
Why? So that it will be divisible by
4.
Ah, very good. Now, why am I finding the sum of digits? To make sure it's divisible by...
It can be divisible by 9.
Yes. Okay, come, let's find the sum of digits. 1, 5, then after that?
9.
Yeah, continue.
9.
Yeah, 9, done. Done already, 9, done. What else?
6.
6. Oh, what is this number? This number is 15ABC6. I want you to find the sum of digits of this number. How do you find the sum of digits? 1 plus 5.
3 plus 2 plus 6.
Good. So can you add them together for me?
21 plus 3 plus.
And now we want this to be divisible by
9.
9. So you say 9 divides 21 plus B plus C. Therefore, B plus C can be equal to what?
6.
What else?
15.
What else?
24.
What else?
33.
So on and so on. Yes or no?
Yes.
What is the biggest possible value for B plus C?
18.
Yes, very good. Because the maximum, it can be 9, and 9, it can be 18. So can I do 24?
No, the maximum is 15.
Very good. Well done. Okay. So the maximum must be 15. Now, do I want to use the maximum 15, or do I want to use the number 6? 15. Why?
Because it's the largest number.
Very good. You want it to be as big as possible. Okay. So Okay, so let B plus C equal to 15. So B equals to something and C equals to something. What do you want it to be? So that it can
9
be
and 6.
9 plus 6. Can C be 6?
No.
Then what can it be?
8 and 7.
Yes, very good. Okay, C can be 7 because we already determined that C must be 1, 3, 5, 7 or 9. So C must be 7. Therefore, what is our final answer? 1, 5.
9, 8, 7, 6.
You got it. Very good, CJ. Well done. Any questions? No? How about the rest of you? Who has any questions? Raise your hand. Okay, so there you go. It is very similar to the previous question, just that this is asking for the largest. The previous one is asking for the smallest. Well done, students. Well done. Let's take a look at question 5. So now you have 72, and we know that 72 is 8 times 9. So if 72 is 8 times 9, we must make sure that the number is divisible by 8 and divisible by 9. Right? So, firstly, can I ask An, how do I tell if a number is divisible by 8?
Define if it's divisible by, you need to observe the last 3 digits of the number.
Very
and
good.
If divisible by 8, then the whole number is divisible by 8.
Very good. Since the number 8 must divide M6, 7, 9, and then the last 3 digits must be divisible by 8. That means 7, 9, n must be divisible by, that means 8 must divide 7, 9, n. So therefore, right, what is n?
It can be 2.
Very good. Because you already know that, okay, wait, let me think how I want to write this. Maybe I just draw another arrow, I guess. Okay, now, very good. Because we already know that the number 800 is divisible by 8, yes? So if students, if you observe 800, right, okay, you observe the 8 times table. The 8 times table. All these numbers are divisible by 8. So you can see that this is the only possible answer. 792 is divisible by 8. Therefore, n must be equal to 2. Well done, An. Okay, so now you know that n equals to 2. Next, we want to make sure it's divisible by 9. So what do I find?
You have to add up all the digits.
What do I call it? The sum of?
Sum of digits.
I must find the sum of digits. Very good. So sum of digits is m
Plus 6 plus 7 plus 9 plus 2.
What do you get?
You get 24. M plus 24.
Excellent. So I must make sure that 9 divides m plus 24. Therefore, what is my value of m?
It can be 3. It can be 6. Wait, not 6. It can be 12. It can also be
On and on and on. You just keep adding 9. If you want it to be divisible by 9, you just keep on adding 9. So then what is m then?
B1 onwards cannot because M is a single, like 12 onwards is a single digit number.
Very good. So 12 onwards is not possible, right? Because M is a single digit number, right? Very good. You are correct. M is a single digit number. You cannot accept double digit 12, 21. You can't. So therefore, what is the final answer?
3, 6, 7, 9, 2.
Well done. Thank you, Eun. Good job. Okay. Students, any questions? No? Anyone raise your hand? Questions? Alright. Then why don't I let you try question 6? I give you 2 minutes. Your time starts now. So now, students, they ask you to find the smallest possible value of 937 ABC so that you can be divided by 3 and 4 and 5. So what does this mean? Let me ask Zachary. Hi, Zachary. Now, if I want the number to be as small as possible, what should I let A be equal to? Hmm?
0?
0. Yes, since I want to let 937 ABC be smallest. Okay, so I'm letting A equals to 0, right? Now, next, we look at the number 4 and 5. If you are able to have a number that is divisible by 4 and 5, then what is the LCM of 4 and 5? Lowest common multiple. What?
It's 20.
20. Yes, you are correct. So LCM is 20. Now, if a number is divisible by 4 and 5, that means you must be divisible by 20. Do you agree?
Yeah.
20 can be divided by 4. 20 can be divided by 5. Right? Yes. Okay, so what can we do next? How will you make use of this 20?
B and C is 20.
Yes, very good. So it's pretty obvious, right? Because how do you tell whether a number is divisible by 20? But are you sure it's 20? Why don't we let it be 00? Isn't that smaller? Because if you want to tell whether a number is divisible by 20, number 100 is divisible by 20, isn't it?
Yeah.
120 is also divisible by 20, yes or no?
Yeah.
Can you see that if you want to, how do I tell if a number is divisible by 20? Look at the last two
The last two
digits. As long as the last two digits is 00, 20, 40, 60, 80, then it's divisible by 20, you agree?
Yeah.
So why are we not using 00? Because you want it to be as small as possible. Why can't it be 00?
Can't be divided by 3.
Ah, yes, because you cannot be divided by 3. Very good. Okay, so why don't we just find the sum of digits? Okay, I think before we do the 20, let's just find the sum of digits. Sum of digits. What is the sum of digits? You tell me the working. 9.
9 plus 3 plus 7 plus 0 plus 2 plus 0.
We don't really know whether we want B and C to be 20 or 00, right? We don't know what we want it to be yet. So can we just leave it as B and C first?
Okay.
Okay, what do you get?
We get we get 19 plus B plus C.
Yes. Okay, so we must make sure that 19 plus B plus C is divisible by
20.
Okay, so Are you sure it's divisible by 20? Why are we finding the sum of digits?
See if it's divisible by 3.
Yes, you must see if it's divisible by 3. So 3 must divide 19 plus b plus c. Therefore, what is the possible value of b plus c?
2?
Yes, the possible value of b plus c can be 2. What else?
5. 8.
Continue.
It's 11. But then it's 2 digits.
Continue.
Right, and then 14, 17, 20.
Now,
22.
where do we stop?
We stop after 20.
You,
No,
so,
we stop at 17.
very good. Okay, you must stop at 17. Why? Because b plus c, the maximum is 18, right? So you stop at 17, very good. But are we trying to get a biggest possible value or a smallest possible value?
Numbers.
Yes, okay, so we must let b plus c equals to 2. Okay? So now we know the LCM is 20, and we must also let b plus c equals to 2 since it is the smallest. So using this and using this, what is b and c? Can it be 0, 0?
2, 0.
Ah, it must be 2 and 0. Very good. So therefore, the answer should be 9, 3. Continue.
9, 3, 7, 0, 2, 0.
There you go. Can it be? Hold on. Can it be 0, 0, 2?
It can't be divided by 5.
Yeah, why don't we just say 20? Can't be divided by 20. I mean, we are not really caring about the number 5. Because we combine the 4 and 5, right?
Yeah.
So we care more about the 20, right?
Yeah.
So we can just say it cannot be 0, 2 because 0, 2 cannot be divided by 20. Yes. So it has to be 2, 0. Thank you, Zachary. Well done. Yes, you raise your hand.
I actually started off with C, then I moved on. I started from C and then I went to B and then I found A from.
Oh, you did it backwards. Can you roughly tell me, like, what do you mean you started from C? How is it possible?
I know because like divided by 5, right? So it has to be either 0 or 5, but then you can't, there's no multiple of 4 that ends with 5, so then you use 0.
Oh, yeah, makes sense. Okay, so C is 0 then?
So then B will be either 2 or 4 to like make it small, but then 2 is smaller than 4, so you use 2. So then you add everything up. 9 plus 3 plus 7 plus 8 plus 2 plus 0. You get 21 plus 8. And then the A, because 21 is like is the multiple of 3, so then you can make A 0. And my initial answer was 937,320, right? Because I go and add 3 to it, and then I realized that it could be smaller if you change A to 0, and they never say the numbers are unique, so it's 937,020.
Very good. That's quite logical, except for one flaw. When you told me that your B equals to 2, now it got me thinking, how do you know B equal to 2? Because if you're thinking of divisibility by 4, 0, 0, 0, 0 is also possible. What? 0, 0 means 100. What? So it can be divided by 4.
And also, like I did like 2 different ones, like using like 0, 0, 2, 0, and 4, 0. And then I removed 4, 0 because it's very, very big. And then 0, 0, if you add it up, you get 19, and then it's like you can't divide it by 3.
Yes. So, do you see the problem of doing it backwards? Because you see, if you do it backwards from C, right? Okay, fine. It's pretty solid. How you got C is pretty solid. It's either 0 or 5, but you know that 5 cannot divide by 4. Therefore, C must be 0. I totally agree with that. But then as you start working backwards to your B, your B is not so solid anymore. I would rather you straight away make A equals to 0. You already found C is 0, right? Then you straight away, you can make A equal to 0. Okay? Then you find the sum of digits. Because when you find sum of digits, immediately you know whether it's divisible by 3. Okay? So that's how you can improve. Very good, Earn. Well done. So students, there's different ways of solving. You can start from letter C if you want. Okay? But just make sure that your logic is solid. Then it is proven, backed up by proof. Okay? Don't just guess. Don't just guess. So let's take a look at question 7. Find the smallest possible value of 7m36n. So you make sure it's divisible by 5, and you must make sure it's divisible by 9. How do you tell if it's divisible by 5? The last digit is 0 or 5, right? For 9, you must find the sum of digits. So why don't everybody go and do scenario number 1, the last digit equal to 0. Scenario number 2, the last digit equals to 5. Then you do the sum of digits for both of the different scenarios. Then you can tell me what is your final conclusion. So I want you to give me your answer in the chat. Your time starts now. Well done, students. You got everyone got it correct. So how do we do this? We do case number 1 and case number 2. Case 1. N equal to 0. What is the sum of digits? (16 plus m). Therefore, 9 must divide 16 plus m. M equals to 2. It could also be, can it be 11? No, it can't be 11. You plus 9, right? Plus 9, can it be 11? No. Because m is a single digit number. So the only possible value of m is 2. Okay? So you can say that, therefore, 7m36n. Now let's move on to case number 2. N equals to 5. Seven m36n, which gives us, so since you know that 9 must divide 21 plus m, therefore m must be 6. Okay, which is too big. So why don't we just leave it there? Okay? So we just say that the final answer is 72360. Because this is smaller than the other. We just want to get the smallest possible answer. Anyway, everyone got it correct. Well done. Let's do example 3. Now, students, remember what we did with our 222 just now? Okay, this can be divided by 7, can be divided by 13. So we know that any block of 6 repeated digits, okay, we write down each block of 6 digits is divisible by 7. So what can we do? We group all of them together in blocks of 6. When we group everything in blocks of 6, if you have 49 digits here, 6 times 8 equals to 48. If you have 8 groups of 6, that will give you 48 digits. There's one more digit that is not part of a group, which is left over. So there will be this last digit here, left over. There will be a last digit here, which is also left over. Okay, so we take These are 48 digits. These are 48 digits. What is left over? 6 square 4. Okay? So you must make sure that 6 square 4 must be divisible by 7. So it suffices to consider 6 square 4. You don't need to consider the entire number, which is super long. We just group them into groups of 6. We know that each group of 6 is already divisible by 7. So you just need to think about 6 square 4, and you must figure out what is the value of the square so that 6 square 4 is divisible by 7. Everyone, can you figure out what is this square? Type your answer in the chat. Remember everyone, how do we tell whether a number is divisible by 7? We take the last digit times 2 and you deduct it from the remaining digits. So let's test. 614, 624, 634, 644. 61 minus 8 equals to? Oh, this is not divisible by 7. 62 minus 8 is not divisible by 7, right? 63 minus 8 is not divisible by 7, but finally 64 minus 8 is divisible by 7. Therefore, the square equals to 4. There you go. Okay, so if you know the rule of divisibility, it's so much easier. Yes, question.
So can you you see 614 is 61 minus 8, right? Like if you want to find the divisibility, if it's divisible by 7. So you see the closest multiple, more than 53, is 6 away, 6 numbers away. So, and because you're only taking the tens place, right? Starting from the hundreds to the tens place, right? So you add 3 to the tens place and then you get 644 from 614.
You totally can do that. Very good, well done. Okay, what did she say? She's just trying to say that you already know the answer is 53, and in your mind you already know that the next multiple of 7 is 56. So you just plus 3. Right? So you take 1 plus 3. Straight away you get 4. Yes, you can do that. Thank you, well done. Okay? Let's move on to the practice question. Same thing here. Okay? We know that every block of 6 is divisible by 7. Oh. Okay, now they're talking about 63. Okay, they're not talking about 7. So 63 is still 7 times 9, so we still need to care about the number 7. Okay, so 63 is 7 times 9. You know that every block of 6 digits is divisible by 7. You just need to make sure that you find something divisible by 9. So they want you to find the smallest value of n. What is n? If n equals to 6, if n equals to 6, that means you have 666, 666. If n equals to 10, that means you have 666, like that. Right? So they're just asking you how many 6s are there, basically. What is the smallest value of n? That will make sure that you can be divided by 7 and also divided by 9. So please use your blocks of 6, and also at the same time, please use the sum of digits. Then you can tell me what is the value of n. Type your answer in the chat. Matthew. Okay, Matthew, tell me. You got it. Matthew, tell me. If I want it to be divisible by 7, okay, just don't think about 9. Just 7. How many 6s do I need? What do you think, Matthew? Every block of 6 digits is divisible by 7. So can I just let n equals to 6 first? since you want it to be divisible by 7, why don't we let n equal to 6 first? Because every block of 6 is divisible by 7. Do you know that? Okay, let's take a look at the calculator. 666, 666, divide by 7. Look, do you agree that it's divisible? Matthew?
Yeah.
If I have 444, 444, do you think it's divisible by 7?
Hold on.
Yes, it is. It is. I mean, that's the rule. That's the rule. Look at the rule. The rule is in front, right here. On the very first page, we already said that every block of 6, can you see this?
Yeah.
Every block of 6 can be divisible. You understand?
Yeah.
So 666, 666 is divisible by 7. How about 111, 111? Can I divide by 7?
Yes.
222, 222.
Yeah. Yeah.
Yeah, 999, 999. Yes?
Yeah.
Okay, so every block of 6 is divisible by 7. So if I say that n equal to 6, do you think it will be divisible by 7?
Yeah.
Yeah, definitely. So now I only need to care about the number 9. So let's try to find the sum of digits. 6, 666, 666. You add all 36. Is this divisible by 9?
Yes.
Yeah, so what is the value of n?
6.
There you go. Easy or not?
Yeah.
You just need to do 7, then do 9, right?
Yeah.
Oh, very good. Thank you, Matthew. Well done, okay? All right. Can n be 0? Oh, yeah. Yeah, actually, if you think about it, right? Okay, the question definitely does not want you to give the answer 0. But if you do give the answer 0, nobody can say that you're wrong, you know? Yeah, really what? Nobody can say you're wrong what? 0 can be divided by anything. Can be divided by 7. It can be divided by 9. Very good, Jacobs. Very sharp, very sharp. But of course, the essence of the question is trying to ask you for the answer 6, not 0, okay? We should modify the question to say find the smallest non-zero value of n. I think that will be a better change to the question. Okay, find the smallest value of the square such the expression is divisible by 7. Again, you have 49 and 49 here. So if I group them in groups of 6, okay, we can write down each block of 6 digits is divisible by 7. So it suffices to consider whatever is left behind, the numbers that do not have a group, which is the last digit of 8 and the first digit of 3. So now you just need to test that this must be divisible by 7. Therefore, what is the value of the square? Come, everyone type your answer in the chat, please. There are 2 ways of finding out whether this can be divisible by 7. Number 1 is you just test it. CJ, let's start from the smallest value, okay? Is this divisible by 7? How do you test? You take 80 minus what?
Minus 3.
Are you sure? Come, you read the rules. What is the rule? What is the rule here? Take the last digit and do what? Double it. Come, let's try to double it. When
Minus 6, that's 74.
is it divisible by 7?
No.
So which is the next multiple that is divisible by 7? What is the next answer? 70 what? 70 what is divisible by 7?
7.
So what must I do?
Let's add 3.
Add 3, yeah? So the answer is?
3.
Sorry?
Add 3.
Yes, you got it. Well done, CJ. But there's another way to do this. If you don't want to do this, okay, if you don't want to test, you can use another way. Can I ask you, right? You look at this 800 and something. Do you agree that 700 is divisible by 7?
Yes.
So since 700 is divisible by 7, you can say that this equal to 700 plus 103. I mean 100 and something 3, right? You agree or not?
Yeah.
So you already know that this is divisible by 7. You only need to look at the 100 and something 3. Then you can just test with 103. You'll still get the same answer. 4 cannot be divided, right? Very good. Thank you, CJ. Well done. Okay, any questions about these, students? Whenever you see repeated digits like that, you group them in groups of 7 because, groups of 6, because you know that every group of 6 is already divisible by 7. Now, let's take a look at question 10. So here we have a perfect square. And I'm sorry, everyone. Please change this to n squared. Okay, n squared. So n times n, which is n squared, will give you a 4-digit number A, B, C, D. Okay? And you must make sure that AB equals to, AB 3 dot CD plus 1. Now this dot means multiply. So when I write down like 3 dot 5, that means 3 times 5, you know. Or 3 dot CD, that means 3 times CD. Okay? So, why don't we look at, and they already told you that n is in between 40 and 60. So why not we just observe the square numbers, from 40 all the way to 60. You observe the pattern. Okay. Okay. You keep on making a list all the way until you reach 53. Students, do you notice something? If you look at the number 53, you will realize that AB equals to 3 times CD plus 1. Do you notice? A, B, C, D. 28 equal to 3 times 9 plus 1. Yes, correct. Therefore, N should be 53. Okay? So students, why did I ask you to make a list? Do you notice that all these numbers at the back, this number is too small, 0, 0. The numbers at the back here are all too big. You will never ever be able to get 3 times CD plus 1 equal to AB. You will never be able to do that because the numbers are so big. But until you reach something like 53, right? Then you already know that this is just a number 9. So 3 times 9 will give you something which is small enough. Then you plus 1, you get 28. Okay? Yes, Anand, question.
You said find ABCD for 40 is more or lesser than n, not n.
Can you say that again? What? Find 40 what?
They asked us to find A, B, C, D and not n.
Oh, sorry. Thank you, N. So what is A, B, C, D? Therefore, n equals to 53, which means A, B, C, D equals to 2809. Thank you, N. There we go. All right. Now let's take a look at the last question. A shop sells donuts in packs of 6 or 13. Now 13 is a baker's dozen. Now 1 dozen is usually 12, but you know in the olden days, right, the bakers, they give 13. Why? Because sometimes, you know, when somebody orders something, they order 1 dozen donuts, for example, then one of the donuts may be damaged, right? Damaged, or so they give 13 just in case one of them is damaged. Then at least the customer will still not complain. They still have 1 dozen, which is 12. They just give an extra. So that's why they say it's a baker's dozen, because bakers, they used to do it last time. Okay, so you can either buy a pack of 6 donuts or a pack of 13 donuts, right? You cannot buy 14 donuts because it either comes in a box of 6 or a box of 13. 14 is impossible, 15 is impossible, 16 donuts is also impossible. Right, so maybe multiples of 13 and multiples of 6 should be possible. Okay, so what is the largest number of donuts that you cannot buy from this shop? Think about it. Give me your answer in the chat. Okay, hold on for a moment, students. Do you know something? Okay, I can bet that everybody, right, is trying to make a list. Are you? Because I see you're taking some time, you know. If you take any longer than 30 seconds to solve this question, right, you are doing it the long way. Okay? 30 seconds, you should be able to solve it. Let me teach you something, students. Whenever you come across such a question, use this formula. A times B minus A minus B. And you will straight away get 59. That is already the answer. 30 seconds. There's a secret technique to solve this question. AB minus A minus B. Okay, if you don't use this method, you end up making a long list. You say, oh, can I buy 6 donuts? Yes, I can. Can I buy 13 donuts? Yes, I can. Can I buy 19 donuts? Yes, I can. Can I buy 20? Cannot. Can I buy 21? Cannot. Can I buy 24? Yes. 6, 12, 18, 24, right? Then can you buy like 6 plus 6 plus 13? 25. Yes. But it's going to take a very long time for you to just make a list. Can I buy 26 donuts? Yes. Can I buy 27 donuts? Then you have to think, 6 plus 13 plus 13. No, you can't. Then, you know, you have to keep on making a list. And then you slowly ask yourself, can I buy this? Can I buy this? So, students, forget about the long method. Straight away use the secret shortcut, which is A, B, minus A minus B. Remember this. This is gonna be very useful. Okay, there are other questions like that. Okay, sometimes they ask you about McDonald's. You go to McDonald's, you can buy nuggets. Nuggets are sold in... Okay, why not? Everybody, I test you. Let's say nuggets can be purchased in a box of 7 or a box of 11. So can you tell me how many nuggets? What is the biggest number of nuggets that I cannot buy? Everyone type your answer in the chat. Very good. It's still 59, right? 7 times 11 minus 7 minus 11. Yeah, very good, students. Now you ask me what's the logic behind this. Okay, it's not really... It is actually discovered. Because we realize that we have been doing the mathematicians have been doing it the long way, but they spotted a pattern. And the pattern is AB minus A minus B. Okay, students? So make use of what other people have discovered. and you will save your time. All right, well done, students. Today we managed to learn about divisibility. We learned all the rules. For number 3 and the number 9, you find the sum of digits. Number 4, you look at the last 2 digits. Number 8, you look at the last 3 digits. Number 7 and number 13, very similar. Blocks of 6 numbers, okay, will be divisible by 7 or 13. Number 7 is a little bit special because you need to take the last number, double it, and then subtract it from the remaining number. So number 7 is a little bit special. Number 11 is a alternating sum. Positive, negative, positive, negative. Okay? Alright, so please take a look at the solutions which will be uploaded in the portal. And the lesson recording for today is also uploaded. You can do your revision and you will improve your understanding. Because next time you'll definitely come across more questions like that. I guarantee you. Alright? So, well done today, everyone. Please do your revision and I'll see you next week. Bye. Bye, Jacobs, Koji, Lian, Matthew, CJ, Zachary. Bye.